Hi everyone. In this video, I'll walk you through an agent-based restaurant reservation system developed using the LangChain framework. I'll explain this project in three parts. First, I'll introduce the project and give you an overview of its high-level architecture. Then we'll go through several live demonstrations to see how the system works in practice. And finally, I'll explain the implementation and walk you through the source code. An agent-based restaurant reservation system should be able to perform the following tasks. Search for restaurant based on user preferences such as the city, cuisine type, and restaurant rating. Make a reservation and generate a reservation receipt and cancel a reservation. And finally, answer general questions related to restaurants and reservations. Here you can see the high-level architecture of the project. On the left, you will find an example conversation between a user and a chatbot. The user says, "Can you recommend some Japanese restaurants in Seattle?" The chatbot responds, here are some Japanese restaurants in Seattle." The user says, "Make a reservation for the Nuri and Nas restaurant for 3 people under the name Mohammad Reza for this contact number and this for this date." And finally, chatbot responds with reservation confirm and your reservation number and shows you the reservation receipt. Later in the video, we will go through the similar example ourselves. In the middle of the diagram, you can see the tools available to the agent. The first tool is search restaurants. It can search for restaurants using 1, 2, or all of 3 criteria shown here. The restaurant information is loaded from an Excel file called restaurant info XLSX. This file contains information such as restaurant ID, restaurant name, brief description about restaurant address, restaurant location, cuisine type, seating capacity, available seats, restaurant contact number, opening hours, and restaurant rating. The second tool provides detailed information about the restaurant, such as its address and contact number. Like the first tool, it also retrieves its data from restaurant info Excel file. The third tool is responsible for creating reservations. To make a reservation, it requires information such as the customer's contact number, the desired reservation date and time, and the number of guests. Before creating the reservation, the tool performs several validation checks. First, it verifies that the reservation date is valid and not in the past. Next, it checks whether the phone number is in a valid format. And it also verifies that restaurant has enough available seats for the requested number of guests. If all validations pass, the reservation is created successfully. The chatbot generates a reservation receipt and stores the reservation details in an Excel file named Customer Reservation XLSX. This image shows the content of this Excel file. We have reservation number, restaurant ID, restaurant name, restaurant address, location, restaurant contact number, customer name, customer contact number, number of guests, reservation date, and reservation created at what time. The fourth tool is cancel a reservation with reservation number. When a reservation is canceled, the corresponding record is removed from customer reservation Excel file, and the restaurant's available seating capacity is updated accordingly. The fifth tool is answer restaurant FAQ. It handles general questions about reservation policies. This tool acts as another Excel file called Restaurant Assistant FAQ XLSX. It uses a retrieval augmented generation or RAG pipeline to answer user questions based on the information stored in that Excel file. This image shows the content of this Excel file. We have 2 columns, question and answer. Now let's run the application and see it in action with some few examples. For the graphical interface, I chose Gradio. I found it to be simpler and faster to work with than Streamlit. If I run this cell, it generates a local URL where I can test the application. I can either use the interface directly here or open the link in browser. Another thing is that if you set the share parameter to true, Gradio generates a public URL allowing you to easily share your application with others so they can test your application from anywhere. Now let's test the chatbot. I've already prepared a few examples prompts so we can move through the demonstrations more quickly. Let's say, recommend me some restaurants that serve Japanese cuisine in Seattle. Alright, the chatbot response. I found these Japanese restaurants in Seattle, Nuri and Not, and this is. Would you like to know more about either of these? I said, tell me more about Nuri and Not. As we can see, the chatbot provides more detailed information about this specific restaurant. Now let's make a reservation. I'm gonna say make a reservation for this restaurant for 3 people under the name Mohammad Reza. This is my contact number and this is the date. There are two issues with this request. First is the phone number is invalid. There is one extra number here. Second, the reservation date is in the past since we are currently in 2026. Let's see how the chatbot responds. I am sorry, but I could not create a reservation for you because the phone number you provided is invalid. Please provide a valid phone number. Let's correct. But I could not create a reservation for you because the date must be in the future. Okay, let's fix this. $2026. Your reservation at Nouri Anat is confirmed. Here are the details, and this is your receipt. Let's open the receipt. You have restaurant name here as well as here your reservation ID or your reservation number. You also see a QR code. If you scan this QR code, you get this reservation ID and other detailed information shown here, like guest name, number of guests, date, time, address, and restaurant contact number. There's another example. Test another example. Let's try this example where the requested number of guests exceeds the restaurant available seat. Make a reservation for 300 people. It says, I am sorry, Mr. Jack, because I said under the name Jack. But a reservation for 300 people cannot be made at Nuri and Not as the restaurant only has 92 seats available. For the last question, let's ask a question which is outside of the chatbot supported domain. I'm gonna say, what is the capital of Iran? It says, I am designed to assist with restaurant-related requests, including searching for restaurants, viewing details, and making reservations. I cannot provide information on capital cities. Alright, we asked our last question. Now we are reached to the final part of the video where we will take a look at the implementation. This is the overall architecture. I already discussed that. Let's move on the code. First, we have the required libraries. By running this command, you can install all the dependencies needed to run this notebook. Then we have libraries. We import Python required packages. In the configuration section, you load your API key. In this project, I'm using an open router API key. For the LLM section, there is nothing to initialize yet. When I'm defining the agent, I have to specify the language model there. In the embedding section, I load text embedding 3 a small model for the embedding. In the loading data section, I load the restaurant info dataset, which contains information about the restaurants. For this project, I create a dataset containing information for 15 fake restaurants. Next, I define tools. The first tool is search restaurants. This tool accesses one or more search criteria from the user. These include the city, the cuisine type, and the minimum restaurant rating. It returns a list of restaurants that match the specified criteria. This if statement checks that the user has provided at least one search criterion. Then the search filters restaurant by city. Notice that the city name doesn't need to match exactly, and the search is also case insensitive. Next, it filters by cuisine type and finally by a minimum restaurant rating. Let's test this tool. Unlike a regular Python function, LangChain tool should be executed using the invoke method. If I run this cell, as you can see, there are 2 Japanese restaurants in Seattle. If I uncomment this line, the results are filtered further, and now only 1 Japanese restaurant remains with a rating higher than 4.8. The second tool provides more information about a restaurant or detailed information about a restaurant. Let's jump straight to an example. Suppose we would like to know more about the Gilded Spoon restaurant. Here you can see the details information about this specific restaurant, such as restaurant name, brief description about the restaurant, restaurant address, location, cuisine type, seating capacity, available seats, contact number, opening hours, and rating. The third tool is create reservation. Before we look at the tool, let's go through the helper function it relies on. The generate random ID function creates a random 6-character alphanumeric ID and prefixes it with R underscore to produce the reservation number. The validate phone number function validates the phone number based on the selected region. It also normalizes phone numbers. For example, it automatically converts Iranian phone numbers to the international +98 format. The get current date time function returns the current system date and time using the specified time zone and formatting. The parse validation date time function parses and validates the reservation date and time provided by the user. Next, I define the function responsible for generating the reservation receipt. I also define 2 variables, is receipt generated and generated receipt name, so that whenever a receipt is successfully created, it can be displayed to the user. The generate receipt function requires information such as the reservation number, reservation name, guest name, number of guests, reservation date and time, restaurant address, and restaurant contact number to generate the receipt image. Now we have reached the final helper function before defining the reservation tool, which is make a reservation function. I'll explain this tool first, and then we will look at the helper function. This function is responsible for creating a reservation for a customer. It requires requires information such as restaurant name, customer name, number of guests, customer contact number, reservation date, and time. The tool first validates the phone number. It then validation date and time. Actually validates the reservation date and time, and then it checks the restaurant available seating capacity. If the user enters 0 or negative number of guests, the chatbot returns an error indicating that the number of guests must be greater than 0. If available seats is equal to 0, it means the restaurant is fully booked. If the requested number of guests is less than or equal to the available seats, the reservation is created successfully. Otherwise, if requested number exceeds the available capacity, the chatbot informs the user of the remaining available seats. Let's assume the reservation can be created. In that case, the make reservation function is called with required information. Then the generate receipt is called and generates a receipt. And the chatbot confirms that the reservation has been created successfully. Now, let's look at the make reservation function. This function reduces the restaurant's available seating capacity based on the number of guests and stores the reservation information in the customer reservation Excel file. Let me show you this file. This is customer reservation Excel file. As you can see, we had a reservation for this customer for three number of guests. Let's test this tool. Suppose we want to make a reservation at Azure Coast Restaurant for this customer name, Alex Wood. Let's first enter 0 as the number of guests. As we expected, we get the number of guests cannot be 0 or negative. Please enter a valid number. Let's enter 5. Before I run this cell, let's look at the available seats. Now 120 for seating capacity and 120 for available seats. I run this cell. Alright, reservation status successful. Notice here. Now available seats is 115. Now let's look at the next tool, which is Answer Restaurant Assistant FAQ. This tool answers general questions about restaurant and reservation related questions. Its responses are based on the data stored in Restaurant Assistant FAQ Excel file. And to build this tool, I implement a retrieval augmented generation or RAG pipeline. First, I can convert the FAQ data into LangChain document object. Next, I generate embedding using the model I loaded earlier and store them in a Chroma vector store database. This piece of code checks whether the vector store already exists or not. If it does, I simply reuse it instead of creating again. Next, I define the retriever and configure it to return 3 most relevant documents. The build context function is for building a context for an agent. It combines the user's question with these 3 retrieved questions or retrieved documents and pass it to agent. Inside this tool, the agent uses this context to generate the final answer. It calls build context with questions here. Let's test this tool. I'm gonna say, how can I book a reservation? Let's see the context. In the context, we can see the questions like, how do I make a reservation? Now let's look at the final tool, which is cancel reservation. This tool first loads the reservation data from the Excel file and checks whether the provided reservation number exists. If the reservation is found, the tool restores the restaurant's available seating capacity based on the number of guests in that reservation. Finally, it removes the reservation record from the dataset and saves the updated data back to the Excel file. Now that we have defined all the required tools, the next step is to combine them into a list and pass that list to our agent. Next, I create the system prompt. In the system prompt, I first define the chatbot rule and responsibilities. Then I specify its capabilities and clearly describe when each tool should be used. I upload the complete source code to GitHub so you can read the full system prompt there if you are interested. Now we are ready to create the agent. For this project, I'm using a Gemini model as the LLM, accessed through the OpenRouter API key. Next, I provide the agent with the list of tools that we have defined earlier. Then I configure the checkpointer, which enables the chatbot to maintain conversation memory. Then I provide the system prompt and assign a name to the agent. We also need to specify thread ID in the configuration because each user should have a unique thread ID if you want to. If you want to start a conversation with a fresh memory, simply use a new ID. The final part is testing the application through the user interface, which I demonstrated earlier in the video. That brings us to the end of the video and project. I hope you found this video helpful and useful. Thanks for watching.